It's important to remember that we continue to study Dmitry Mendeleev to this day, not because he was the first person to develop a periodic table and not because he was the last person to develop a periodic table, but he views the information on that periodic table in a brand new way. He took that extremely brave step of leaving holes on the periodic table for elements which had yet to be discovered. That's something that no other scientist did, and why he is actually of note and why we still study him to this day. Speaking of days, I think it's also important to understand, historically speaking, where Dmitry Mendeleev and periodic table history meshes up with atomic structure history. We see that his contribution falls somewhere in between the works of Dalton and Goldstein and Thomson. Now, remember, they were really to talk about the positive and negative charges on the inside of the nucleus. So really, the only leading idea at this point was the work of Dalton, and he still believes that the atom is mostly just a solid sphere. They don't understand about subatomic particles. So Dmitry Mendeleev didn't have the benefit of that perspective. All he had were these general masses of the elements, and he did his best to organize them. This is a page from Dmitry Mendeleev's actual notebook. This was his first periodic table. Now, this obviously looks nothing like the periodic table that we use today until you rotate it about 90 degrees. If you kind of squint, you can kind of maybe make out the outline of our modern periodic table, but you really got to work at it. What's important to note here is that from left to right, he had organized this periodic table based upon increasing mass of the elements, and that from top to bottom, that he organized it based upon similar properties. Now, this was extremely controversial in the time, and a lot of people liked to challenge him, but yet his periodic table kind of stood the test of time. That is, until we have another notable scientist who said, yes, I agree that we need to be organizing the periodic table based upon similar properties, but this whole mass business, well, that's for the birds. This scientist is by the name of Henry Moseley. He's an English chemist, and his major contribution is really because of where he falls in time. Now, Henry Moseley is contributing to the periodic table after the work of Rutherford. So at this point, we understand that the proton is locked inside of a nucleus and that there are electrons around the outside. More importantly, we understand that the proton is the most important particle for distinguishing one element from another. So if we're making a periodic table of elements, it made sense to Moseley to include the number of protons on that chart. And then he developed an alternative to the periodic table. Now again, it's important to note, Moseley knew about the subatomic particles. Mendeleev didn't. Mendeleev only had the masses of those elements. So Moseley's periodic table looks like this. It looks tremendously different, but if you look really close, you'll see those tiny little differences. And I'm going to challenge you later with trying to figure out what a couple of those are. From left to right, instead of increasing mass, Moseley said it's organized based upon increasing number of protons. But still, from top to bottom, he says it's organized based upon similar properties. And we'll learn a little bit later in subsequent videos about what those properties are.